Okay, so today is a review day. We're just going to do practice problems. I will not have time to type the review like I usually would, but still, we're going to do practice today, and it's just going to be problems that are similar but different to the ones I'm going to post. And on that note, the plan for this class, math, also, hi everybody, hope you're having a good day. Just chit chat on the side too. I totally lost internet connection yesterday, so I'm back at my parents' house using their internet. But I still have I'll still be able to post your test. We still will be able to meet Friday. But if I haven't responded to your emails, I'm working on that. Hopefully, I'll do that today. So, okay, we can do this though. Exam 1. I have decided to create on Canvas. So that I can grade it and I can give partial points. You don't have to show your work. You can work with each other. Just please talk to me or talk to a classmate before talking to a tutor. The goal is to get as much practice as we can. So make sure you understand what's going on. All right, let me find the plan. So, oh, wrong binder. Okay, so wrong binder. Where did this binder find? Okay. Yeah, I was going, by the way, for the chat, I was going to make the test on WebAssign, but it would be kind of just like homework. And when you get the problem wrong, you don't get any points. So I'm going to type it on Canvas. It should be able, you should be able to write your responses, but if you have trouble typing it in, just, let me know. Okay, so let's see. Picked 10 problems. So it will have like a place for an essay response, but again, you don't have to show your work. You can just put in the answer. I'll write this all in the instructions. Okay, any questions or concerns? All right, we're going to let's see. Gonna go kind of in order, the order in which I'm going to post these kinds of problems. So starting with these guys, number 1 and 2. All right, make sure I don't give you the problem I want to test on. So v of x equals 1 minus 2x. V prime of x. And you're given that v of 3 equals 4. V of x. So we call something like this an initial condition, and what we're going to do is integrate this differential equation to get that function. Integral of 1 minus 2x dx. And we have, let's see, x minus 2 with x squared over 2 plus c. That's a little better. Okay, and then we're going to solve for c. So first I'm going to put in 3 for x, and then we're going to replace v of 3 with that value that you were given. Okay, trying to get nicely set up here. All right, 3 minus 3 squared plus c. Okay, now let's replace this. It was 4 for v of 3. We've got 3 minus 9 plus c. All right, we're still good. Okay, got c equal to 10. And then the solution, or the function, x. Yeah, v of x. It is x, subtract x squared, then add 10. So if all you wrote was this part, I would give you credit, but please write the whole, like the function equals everything that you've solved for. Just write this whole thing as your answer. And if you're going to type this, which I know you actually in the essay response section, you should be able to put equations in. But if you can't, you can type this as x minus x squared add 10. So x to the power 2 plus 10. I'll do my best to understand your answers. I'm not trying to be tricky or picky. I'm trying to help you practice. Okay, one more like this. So your new function is called p. And it's p prime of t. Okay, p prime of t is 2 minus 6x. No, so 2 minus 6t. Okay, we find, actually we're given an initial condition, and then we're going to find the original function. So also p of 1 equals 5. Okay, find the function p of t. So we integrate the differential equation, or just the integral of p prime of t equals p of t. And put that function in. 2 minus 6t dt. and we're here. So 2t minus 6t squared over 2 plus c. And you have to find c. So we use the initial condition. Let's plug in 1 for t, and then after that we'll replace p of 1 with 5. Okay, 2 times 1 minus 3 times 1 squared. Now, so this was 5. Okay, 2 minus 3 plus c. So I got c equal to 6. And so my function was p of t. It is 2t minus 3t squared plus 6. And again, you can put the little caret and then 2, and that will be the power 2. If you have trouble typing these things, again, just let me know, or just even as underneath what you've typed, you can let me know if it was difficult or not. Okay, let's see. This is a good one.
Professor, I was wondering, did you want that in order, by chance?
Oh yeah, it doesn't matter how you've arranged this, as long as it's correct. I'll give you credit.
Okay, thank you.
Yeah, sure. Oh, and let's do something else. So the next kind of problem. Okay, we're gonna do some U subs. So from my packet. Okay, this is a good one. This is a nice place to start. The integral of e to the 4x dx. So we could let u be 4x and just go through a whole u sub just to be sure we get the right answer. But there is a rule for this in the book. E4. Let's see, I like to solve for dx, so I would divide both sides by 4. And then we'll replace this right here. And this will be written as e to the u times du over 4. So this is on scratch work. Let's bring that 1/4 to the front, and then e to the u du is what we're going to integrate. The integral of e to the u is e to the u, so 1/4 e to the u. Make sure you replace u with that x variable, so e to the 4x over 4. Let's see. Okay, next one. Okay, let's try number 5 from my packet. So okay. And yes, I'm trying to give you questions that are similar, which is why I'm making comments to myself, so that way I give you a problem that's close to this problem. All right. Let's give this a go. Sine of root x over root x. It's a u sub, where we let u equal the root of x. Let's make this some space. Take the derivative, du dx. 1/2 x to the negative 1/2. Okay, first I'm going to multiply both sides by dx. And this is going to be 1 over 2x to the 1/2 power dx. So I brought this in the denominator, got this dx over here, and I'm thinking that I want to write this x to the 1/2 as u. So let's give this a try. Let's put it all in here and see what happens. Integral of sine of u. Okay. And then let's go one more step at the bottom. So 2 times u du is equal to dx. So what is this?
I just did have a question. So the derivative of the x squared, I thought it was I'm sorry, I scratched it out.
Okay.
I thought it was something. The du over the dx, I thought it was equal to x to the negative half times -2.
The power, so what you bring down
I'm
is,
sorry, the third one right under that.
oh yeah, here.
Du dx.
Yeah.
Sorry. No, right above that. The one, right? Yeah, that one. I was saying that one. Can you go over how to get that one more time?
Okay. From the power rule, you bring down this 1/2 power, so multiply 1/2 with x, and then subtract 1 from that power. So 1/2 minus 1 is going to be the negative 1/2.
Okay, I keep getting confused with the anti, and I keep like trying to multiply it by
Oh
the
yeah,
exponent. Yeah,
this is the antiderivative, and over here we're taking actual derivatives.
got it. Okay, thank
Okay,
you.
sure. I think that we will still piece this together. Thanks for asking questions. My root x is going to be written as u, and then my dx is 2u du. Okay, the u over u is going to reduce. This 2 will bring to the front. And then let's see if I could get this. Sine, beta cosine of cosine would be negative sine. I think we need a negative here. So a negative 2. Negative 2 cosine of u, let's check. Cosine would be negative sine. So I should get back this way. Let's see. Yes. All right, and then put in that value u. So make sure you go back to the original variable. So we have a root x in here. Negative 2 cosine of the root of x plus c. Which this is probably a problem I wouldn't pick because it's difficult to type, but I still have problems that are similar, like similar ideas. Let's get this. Okay, and then for these integrals, just put in what your answer is. You don't have to show all of this work, or just do your best to type your solution. All right, let's see what else we can do. Okay. I think we're gonna try this. Let's see. Let me check one more time and pick another one. Okay, I changed my mind. Let's try this one instead. So we're gonna go in here and do this. Okay, we've got the integral of the cosine of ln of x dx, or over x dx. It's a u sub, so we pick u as ln of x. And then the derivative is du dx. And I like to solve for dx, so du equals 1 over x dx, which makes, okay, that's cool, x du equal to dx. So we'll plus this, replace that with that, and write this here. Cosine of u over x. And dx is x du. So the x's cancel, and you've got the integral of the cosine of u du. Let's see. Sine. And then put in that value for u, which was ln of x. So the sine of ln of x plus c. Okay. Let's see. I'm feeling like we've done a lot of trig problems, so I want to pick something kind of different. Let's try. Okay. Cool. Okay, we're gonna try this one. We're running out of time. Cool. Let's go with this. The integral. 3x minus 2 over 3x squared minus 4x. Okay. So u will be 3x squared minus 4x. So the derivative, do that. Six x minus 4. Cool. Multiply both sides by dx. Also, we'll factor out a 2. Nice. And then I am going to solve for dx, and then I'm going to replace that dx with this dx right there. So I'm just going to need to erase this and put u as the denominator. 3x minus 2. Okay, 3x minus 2 over 3x minus 2, and this 1/2 will bring to the front. Okay, so 1/2 times ln of the absolute value of u. And then u was 3x squared minus 4x, so this is 1/2. I'm just going to put it in right here. Okay. So again, I would like to give a similar but different problem, hopefully something that's a little easier to type. I want to make sure we cover all the topics, so we're going to put u subs to the side and then go on to my list of questions. So let's do this. I'm going to sketch and stuff. Let's say that was do it like this. Use integration to find the area. The region. Okay, let's see. I feel like we should do 2 problems like this. So the first one we're going to do is going to be y equals 4 minus x. Let's put between. Y equals 4x and y equals 4x minus x squared. For 0 less than or equal to x less than or equal to 4. I might just use Desmos to help sketch the graph. I'm a little iffy about this graph right here, but this is easy. This is a line with an intercept of 4 and a -1 slope. So let's get that. Here. Up. Down 1 over 1. Out. All right, let's see how this other graph looks. Oh, actually, we want the Desmos graphing calculator, which is free on Google. want to graph. Y equals 4x subtract, oops, minus x squared. So it's an upside down parabola and its vertex is at 2, 4. I'm going to go through the origin and over to the point 4, 0. Find a way to stop this. Cool. So we'll try to draw this parabola. Yeah, it does most sense. Okay. Right here, a little curve like this, and then through there, and then up, and over like that. Okay. So what we need to do is use that rule where we find the top function and then subtract the bottom function. So this is how we're going to put everything together. And actually, first we're going to shade in the area. Do this top function minus this function to get this part. And then this one minus that one. Okay, again, I'll make some kind of similar problem. We're going to integrate from 0 to 2 the top function is the line 4 minus x. And subtract the bottom function, 4x minus x squared. Then continue, because your x values are between 0 and 4. So pick it up again at 2 and go over to 4. And now the top function is the parabola, that 4x minus x squared. And then subtract the bottom function, which is 4 minus x. Okay. I think I'm going to just leave that there and start drawing and sketching the next problem. I have a few more problems to get through, but this setup is good. And just dot, 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 integrate. So you would combine like terms, like, get this negative sign, get the values together, and then do the integral and plug in the, and then evaluate from 0 to 2. Same thing here. Just expand, integrate, and evaluate. It shouldn't be too bad. But let's move on. So this one, we've got the same setup. Find the area between sine of x. Let's do y equals. We're going to make this one a little bit different. So this one's just going to go from negative pi over 4 to positive pi over 4 for x. Okay. let's make this pi over 2. So yeah, this is pi over 4. Okay. Let's start with, I'm going to start with cosine. Cosine starts at 1, will come down, and then it should go through at pi over 2. So we're going to come down like this. Continue. Okay, sine starts at the origin and then comes up. It has a peak above pi over 2, and then it'll come back down. But it comes up. We're going from x equal to pi over 4 to positive pi over 4, which actually is right there. Okay, and then we're going to cut the function off here so we don't have to worry about anything over this way. And we can erase this if you want to, just this piece here. So let's see, the top function is cosine minus the bottom function, which is sine, and we integrate from pi over 4, negative pi over 4 to positive pi over 4. Cosine of x minus sine of x. Oh no. Okay, we only have 3 minutes. Let's try one more. So, you would integrate and then evaluate from negative pi over 4 to positive pi over 4. And I think we should try a problem like that where I'm not going to do any more trig. I feel like we've done a lot of trig today. So, try to get one more example in. Okay, the integral from 0 to 1 of, let's just do x times 3 minus 4x dx. So try just expanding 3x minus 4x squared. And go from 0 to 1. Okay. Integrate. So 3x squared over 2 minus 4x cubed over 3. Evaluate from 0 to 1. So you first put in 1 through the whole expression. And then subtract, putting in 0. So 0 for x. As it turns the whole thing. Okay, that's a 0 and that's a 0. So this is all minus 0. I think we can write the answer 3 halves minus 4 thirds. And then you can write, you can get that common denominator and write the fraction. You can put this in decimal form. Just try to simplify your answer. But I'm just going to end it right there. Okay, so those are all the ideas. I've made notes to myself of what we've went over today, so I'll make problems that are like these problems. And again, it's going to be posted to Canvas. I will post 10 questions total, and they're due a week from today. They'll be up at midnight. And so you can start on them tomorrow, and you can ask questions on Friday. Okay, thank you. Have a good day. I can't type this up, but hopefully the review questions were good enough. Bye.
Have a good day, Professor.
Thank you.